Welcome back, and for new folks tuning in, welcome to the final session of our five-part mini-series focused on modernization. Hey, we've covered a lot of different content over the last 4 weeks, so thanks for hanging with us, and I think today you'll find the wrap-up of our mini-series here to be very useful and applicable to your current environment. So like I've mentioned in the past, these sessions have been recorded. If you've missed previous sessions, definitely go back and tune in to part 1 through part 4. Everything is intended to build on top of previous sessions. And just as a reminder, we will be providing this recorded session to everybody as a follow-up. But if you do have questions, please chat them in. Our moderators will help answer questions as they come in. And finally, if you'd like to hang out and ask questions live, we will open up the session for Q&A at the end of our talk here, which should be about 20 to 30 minutes. So again, the focus here today is really about increasing productivity. So how are we going to do that? We're going to talk a little bit about providing flexibility, mobility, and optimizing control system in ways that will be conducive for modernization, and we'll speak to exactly what that means and how you'll take advantage of the investments you've made over the different content we've covered in part 1 through part 4. And this is a reminder of what we're working towards as we think about modernizing a control system, and the end goal is really to bring a modern connected enterprise to life. And what that means is if you are a manufacturer, you are generating an awful lot of data on the plant floor. You likely have multiple facilities that are generating a wide array of data. So the question has been, how do we do and make the right decisions based on the data that we're capturing? So once we've worked through modernizing your control system and providing actionable information through a variety of different sources, the value to you is that you will be able to better control your manufacturing processes, provide better insights into and make informed decisions about what's happening across your production's operations. And then because of that increased focus and awareness of what's happening where across your entire enterprise, you'll then be able to turn that value over to your end customers and hopefully drive better, more productive relationship with the folks that you work with or folks that you buy from. And finally, just to revisit, so we've talked a lot about smart connected systems and modern control systems and how they enhance the connected enterprise. Today, we're going to be very focused on, similar to our last session, but through a slightly different lens, really the information management. We'll talk a little bit about mobility and also hit in on integrated control and information. But a lot of this is done through really the combination of these different components of a smart connected system. And that is, we've got smart devices that provide insights. We extend the capability of those smart devices into our control system and then visualize them and mobilize that data. We're able to compute on the edge or on-prem, and we're able to generate all of this data through this new modern connected network that's been developed over the last couple of sessions. So we will be focused on this last bullet point here today around an effective execution of a modernization strategy, and we're going to really be working towards enabling flexibility and mobility. The reason we're doing that is to drive productivity through your maintenance team, your operations team, and engineers that interact with your control system daily. So what are a couple of different ways to increase productivity? There's been a lot of talk, especially over the last 2 to 3 years, about predictive analytics and predictive models. I think the reality, though, is that while there's been a lot of talk there, there is an awful lot of work that needs to be done by people that are well informed in your manufacturing process, and that collaboration or that work is primarily done by data scientists, right? So they are collecting data sets, they're cleaning and organizing data, and these groups spend a lot of their time after that data has been captured, right, in analyzing and building out a strategy then to go execute against what's been captured. So because of that and the amount of time and investment and resources required to do that work, we wanted to convert a data scientist, if you will, into a module. So we understand our control systems and the capability of our hardware extremely well. So our data scientist team developed a control algorithm and module that will reside in a ControlLogix chassis that provides predictive analytics directly with very little user input. So the way that we do this is through initial configuration. We then identify data. We build a model to represent what's been found. We monitor that model and the data that's input into the control system, and then generate analytics that can be used to control manufacturing processes more tightly. So here's exactly what that workflow looks like. But essentially what you'll do is after you install this FactoryTalk Analytics Logix AI appliance into a remote or a local ControlLogix chassis, you would then browse to and define the tags that you care about in a given application. So in this case, we're going to select controller outputs that we think may be associated or that we would like to monitor and generate a model for. After we've selected an output, then what we'll do is go select a range of inputs that we think may impact that given output. So this can be a range of variables. It can be near limitless. So since what we'll do then is after those inputs have been selected is we'll put the analytics appliance into a learn mode. And during that learn mode, we will determine exactly which inputs are truly related to that given output. During that learn mode, a model is then built that represents the relationship between the identified inputs and the selected output. And we'll transition that device then from a learn mode into a control mode. So once the device is in a control and listening mode, the Analytics AI appliance will continuously monitor that process. And when a problem is predicted, so if we navigate outside of an expected performance window, we will then set a tag in the Logix controller that will notify you that a problem is predicted. Now, this is not closed-looped control. So because we are monitoring a process and changing state of a given tag in the controller, we would, in this case, suggest you have somebody that's very familiar with a given process to then make a decision about what should be done when a problem is predicted. So we're just giving you insight that we're predicting something will change rather than then making a decision about what to do when that problem is predicted. That portion of the application will be up to you and to your experts. There's two different modes of operation for this device. So we can be in an anomaly detection type mode. So we're going to create a model of normal operation and then detect anomalies against that normal operation. The other mode type that this appliance can run in is what's called value estimation. You may have heard the term soft sensor in industry, but essentially we create a model from existing data, right? So historical data can be loaded into this appliance to generate a model, and then we will use that data to estimate another value. So these two modes cannot run simultaneously. You're selecting to run in operational mode or value estimation mode. What is unique though is that you can cascade the operational monitoring mode. So you can have multiple outputs being monitored with multiple cascaded potential outputs and inputs associated with the cascaded model. And we've talked a little bit too about this need for greater flexibility and mobility in a control system. If you think about the assets that exist in a modern system today, you've probably got a mix of HMI type content. That content may be Rockwell, it may be non-Rockwell, but it probably exists on a PC somewhere. You might have a CMMS system, so you are continuously monitoring your maintenance system and really leveraging that technology to generate work orders. You may even have your control system tied into your business system, so an ERP. A lot of customers today are taking advantage of IP or USB-based cameras so that they can see what's happening live in a given area that may be difficult to get to. You might even be using different on-machine operator interfaces that have support for VNC type technology like our panel views or other operator interfaces. There's a lot of different technologies out there that leverage VNC. So what Thin Manager does is acts as a wrapper around all of those different content types. Think of Thin Manager as a user interface to define and manage all of that different content. And then what we'll do after that content is managed by Thin Manager is start to push that content out to a variety of different end devices. So those devices could be thin clients, they could be mobile devices. So we have applications that are no cost for Windows tablets, for Android tablets, and Apple devices. They might even be PCs. So you can install a desktop app on a Windows PC that connects back to the Thin Manager application and convert that PC into a pseudo thin client, if you will. We can also then couple that content delivery type of sending content to devices by extending that by sending content to different users. So in this case, imagine you've got different user groups, right? Maybe you have an Active Directory today that represents your maintenance team and your engineers, or maybe you have different individuals that should have different levels of access to different types of content. So a great example here would be if you were a maintenance person and you walked up to a given terminal, you sign into that terminal and you're delivered your CMMS system, but you do not receive your business system. So you can have different rules defined by different users and user types or user groups. And after that maintenance person walks away from that terminal, an operator can walk up to the same terminal, sign in, and then receive HMI content for that specific area. So we can get really creative with what content goes where and what users have access to content in given areas or given devices. And then finally, we can extend the capability by really getting creative with location-based services. So imagine in this case, one thing that we can do here is we could generate a QR code. We could have that QR code associated with manuals or documents, and maybe a good example is an MCC lineup. and that MCC lineup has multiple devices installed in it. It was configured from the factory, and there are drawings and different lockout tagout procedures associated with that given MCC lineup. So imagine walking up to an MCC with a iPad in your hands, scanning the QR code, and receiving all of the information related to that MCC because you scanned the QR code at that MCC. So we can also do some really creative things like do what's called geofencing. If you leverage the strength of a Bluetooth signal or the strength of a Wi-Fi signal, you could walk into a Bluetooth geofenced area and receive content directly on a wireless device. When you then walk away from or walk outside of the geofence defined area, that content gets pulled from your device. So any one of these different content delivery mechanisms can be combined with the others. So we can really change the way that users interact with given assets or given control systems based on the devices or users or locations that they're operating in. In addition to extending these experiences out to mobile devices with FinManager, you can also install a no-cost application called FactoryTalk Team One on a mobile device, and with a Wi-Fi connection into your control system or into your control network, we can do really interesting things in this platform, like monitor tags directly in controllers. We can go online with a VFD and watch the speed of the VFD or the motor that's being controlled by that VFD change. We can watch and monitor for system health. We can assign or subscribe to the push notifications that were covered in the FactoryTalk Analytics for Devices appliance. So those notifications can be seen directly on a mobile device. And we can do some other really cool teaming things like troubleshooting and sharing and documenting practices all in this environment. So this is intended for a maintenance team to better collaborate and see exactly what's happening in the control system from a mobile device. And over the last year, especially as the way that we interact with each other changed, and the way that we interacted with machines and devices and had to maintain social distancing, one of the technologies that has helped solve and relieve some of these different market pressures has been remote assistance tools. So with remote assistance, we can really close the gap with worker skill gaps. We can also work through complex products and workspaces by having remote domain experts support folks in the field looking at live assets. And we can also even provide better customer support by, as maybe an example being, a system integrator that is from Oregon but delivered a system to the state of Virginia, be able to remotely troubleshoot that machine as a service through a mobile device. So the way that we do that is through a service called Euphoria Chalk. Rockwell has been partnered with PTC, a leader of digital platforms for coming up on 3 years now. And one of their technologies is called Euphoria Chalk. So this is a real-time remote assistance and collaboration tool. Think of it as a more advanced FaceTime session with the ability to generate augmented reality experiences directly on the screen to accelerate problem resolution, reduce the cost of technician and expert visits on site. We can also improve uptime, can connect to the right resource at the right place and not have to travel to the end site to be able to do that troubleshooting. So the way it works is the the host, if you will, of a session would connect to a user, and those users would then see an over-the-shoulder view of whatever it is that the end user is pointing their camera at on their mobile device. So we then combine that live video stream with audio and augmented reality annotations on both users' view of the given camera view. What's really great about this is because this is an augmented reality experience as a customer moves from one given focal point to another focal point. If you then navigate back to a previous focal point, those augmented reality annotations stick to that environment. So in this case, you can see kind of a light example of that on the screen. The green arrows all indicate annotations that have been made by somebody else to the left of what the camera is currently looking at. And one recent acquisition of Rockwell Automation has been in a CMMS platform called Fix. So Fix is a very robust and flexible CMMS platform designed for the manufacturing plant floor. And Fix really fits into the software ecosystem, as I mentioned, as a CMMS platform. But it has been designed to be integrated both up into a business system as well as down into the OT network, and has system awareness and asset management awareness of control devices of not only Rockwell Automation, but many of the automation vendors that provide solutions into the industrial automation space here today. So here's a really great example of reference of the different ties that Fix can have into those business systems. So on the far left, you see some examples that range between SAP and Oracle, some of the very common platforms, some of the less frequently used platforms like Sage or Infor or Workday or Tableau. There are all integrations that can be tied directly from Fix into those business systems. And then moving down into the OT space, again, because of their wide range and familiarity with the OT space, got the ability to capture information from a variety of assets from different control system providers, as well as IoT sensors and historians, and even down into different fleet devices. So their whole platform sits in between production systems and business systems and provides a couple of different capabilities. The core capabilities are asset management, work order management, parts and supply management, and then reporting and analytics to help make data-driven decisions. Now there's a couple of really cool AI-driven type utilities as well, like Fix Foresight, which will predict maintenance failures based on history, and then also the Fix Integration Hub to tie connect the Fix CMMS system basically to any of the systems that we've talked about previously. And here's just a little bit more detail about each one of the different modules and capabilities that exist within Fix today. So this is a very robust platform that is designed to be quick to value and very easy to use for maintenance teams, for operations teams, and those that are in the plant floor environments daily. So that brings us to a wrap on our modernization mini-series. We've had a lot of great questions over the last 5 weeks. We'll open it up to final set of questions. Just want to say thank you to everybody for tuning in and appreciate your input. And we hope, again, that this has been insightful and useful information for you as OEMs or machine builders, manufacturers of finished goods, as well as system integrators that help deploy these types of solutions for customers globally.